we are going to be looking at how to solve a system of linear inequalities. We're going to be doing that by graphing. And so that's generally how you would solve systems of linear inequalities, is you would graph the system, look at where they intersect, and then where the planes intersect, and that would be your solution set. And so for the first one, we have two inequalities that we want to consider simultaneously. We have y is less than 5x minus 1, and we have y is greater than or equal to a negative 2/3 x plus 2. So just for ease, I'm going to kind of color coordinate these. So the first one, inequality 1, I'll do in red. And then the second one, the inequality 2, I will do in blue. We're going to graph both of these on the same plane and then shade and see where they intersect or overlap. So for the first one, if you don't know how to graph inequalities yet, of these linear inequalities, go to watch a tutorial on that. I have provided a video for that. So feel free to watch my video or another video explaining how to do that. But I'm going to kind of assume you know how to do that as we work through this. So -1 for the red, the first one, -1 is our y-intercept. And then we're going to use the slope, which is 5, or 5 over 1, to draw some more points on the line. So we would go up 5 over 1, or we could go down 5, left 1. And then we would connect that. Since it's a less than, it's a strict inequality, it's not or equal to, it's going to be a dotted line that connects those. Okay, and that's supposed to be a straight line. That's pretty wobbly, but we'll assume it's a straight line. Okay, now I'm going to do the same thing for the blue inequality, or the second inequality. My y-intercept is 2, and then I have a slope of negative 2/3. So down 2, right 3, or I could go up 2, left 3. Okay, and so now since I have a greater than or equal to, I'm going to connect it in a solid line, and that's because it had the or equal to. All right, so I've got the boundaries drawn. Now I need to shade. So if I'm looking back at my red inequality, I have the y isolated on the left, so I can use my trick of less than means below, greater than means above. And I don't have to get test points. So for the red, y is less than, so it's going to be below that line. So that would be everything below the red line. Okay, so everything over here is all going to be shaded for the first inequality. Okay. And now for the second inequality, the one I have highlighted in blue, that says y is greater than or equal to that stuff. So greater than, since I have the I isolated on the left, it's going to be above. So everything above that line is going to be included. Everything above that line. So hopefully you can see that means that our solution to this system of inequalities is everything that's shaded red and blue. So that would include everything in what I'm going to kind of shade in black. Right? So all of this would be included in the solution set to the system of inequalities, because that's shaded red and blue. Okay. Number 2, there is an extra stipulation here, or 2 actually. Look at the last 2 inequalities. So in the last 2 inequalities, you have x has to be greater than, x has to be greater than or equal to 0, and x or y has to be greater than or equal to 0. So if x is greater than 0, that's above that axis. And if y is greater than or equal to 0, that's to the right of that axis. So notice that the only part I'm looking at is quadrant 1, which is the positive quadrant. So really I could have left off all of the other quadrants and just focused on this quadrant. You might see that a lot in some examples that you can encounter in business or computer science. Sometimes they will have that extra stipulation. They are only dealing with positive y and positive x values, or I should say non-negative, because you could have 0. So again, those stipulations are just telling you only focus in on what's happening in quadrant 1. Okay, so I'm going to delete all of that highlighting here, or erase it. So we're only worried about what's happening in quadrant 1. Okay, so I guess I can go ahead and just again highlight that it's just that stuff. Now I'm going to go ahead and look at the other two inequalities. So what's in red, the first inequality, I need to get the y by itself. That's my first step. So I have 3x minus y is less than 2. So I would start by subtracting off 3x from both sides. And so that would give me negative y is less than negative 3x plus 2. And then I need to get rid of the negative in front of the y, so divide everything by negative 1. And that's going to give me y is now greater than 3x minus 2. So remember, if you divide by a negative, you flip the inequality symbol. Okay, so there's my first linear inequality. So I can go ahead and graph that. So negative 2 is my y-intercept. My slope is 3, so I can go up 3 over 1. And then I would graph that with a dotted line because it's not or equal to. And I can really just stop there. I don't have to continue going down below the x-axis because remember we had the stipulation that x had to be positive or non-negative, and so did y. Okay, now I need to figure out how I'm going to shade. So this is y, and I'm going to look at my transformed inequality, not my original. If I'm going to look for shading purposes, I have to look at the inequality that has the y isolated. So this is y is greater than 3x minus 2. So that's going to be everything above that red line. It's everything above the red line. And remember, I'm not even going past the y-axis because I already said that that's a constraint. So everything in this section would be included. Now I'm going to go to the next inequality. The 2x plus 3y is less than 9. And I'm going to do the same thing there. So 2x plus 3y is less than 9. I'm going to solve for y. So minus 2x from both sides. I get 3y is less than 2x plus 9. Divide by 3. So y is less than negative 2/3 x plus 3. So I can graph that. I have 3 is my y-intercept. And then I'm going to go down to right 3. Down to right 3. All right, and so now I'm going to connect those, and it's going to be a dotted line as well because there's no or equal to sign. Okay. And then I'm going to look for shading. So since it says y is less than that, and again I look at my transformed inequality, y is less than that, it's going to be everything below that line. So I'm really only looking for what's shaded red and blue. And so hopefully you can see, I guess I'll use green, let's try green, that it's just this part right here. I don't know if you can really see that. Let's try this darker color. So it's this little section right here. So that section that has been shaded in red and blue I can even hatch it, I guess. All of this section is what's included in our solution set, right? So that's above the x-axis, which is this criteria, the green. It's to the right of the y-axis, which is that criteria, the yellow. It is above the red line, and it is below the blue line. And so that little hatched area right there is all the ordered pairs that would make that work.